Hi chemists, in this video I'm going to talk about dilution of solutions. Oh, rhyming, a little bit Dr. Seuss. But anyway, dilution is the act of adding more solvent to a solution. Okay, therefore the concentration of a diluted solution will be lower than the original concentration, because if we talk about moles per liter, if we're increasing the volume of the solution, we're increasing the bottom of that fraction, so the number is getting smaller. Okay, when you increase the denominator, the number gets smaller. Okay, so the smaller concentration when you're diluting. Don't get it around the other way. The volume will increase, however the moles of solute will be unchanged, and that's what I've tried to show in this diagram here. So here I've done a simple model. I've said there's kind of 1 liter here in my model, and I've got a homogeneous mixture of water and these yellow dots. So it must be a solution. It's a homogeneous mixture, and we've got 1, 2, 3, 4, 5, 6 dots in the 1 liter. So I just said let's call it 6 moles per 1 liter, 6 moles per liter. Okay, and I'm adding in this beaker here, which is another liter of water. And what it ends up being then is this solution to the right, where we've increased up to 2 liters, but we still have the 1, 2, 3, 4, 5, 6 of those moles. So now I've got 6 moles in 2 liters. 6 divided by 2, it's 3 moles per liter. Okay, so I've doubled the volume and halved the concentration. Okay, since the number of moles of solute remains unchanged, we can equate the two values. Okay, so we're going to use the formula up the top and then a bit of dimensional analysis down the bottom. So if the concentration equals the number of moles divided by the volume here, the number of moles equals the concentration times volume. Just rearranging that equation. Now the number of moles before dilution is going to equal the concentration before dilution and the volume before dilution. And they've just said that's the condition 1. And then the same as 2. Condition 2, the concentration to 2 is going to times the volume by 2 to equal the number of moles after dilution. But the number of moles remains unchanged, so then you can equate the concentration of 1 times the volume of 1 times the concentration of, the concentration of 1 times the volume of 1 equals the concentration of 2 times the volume of 2. This could be diluted, concentrated. Okay. So down here I've kind of done the same. The moles of the concentration equals the moles in dilution. So therefore I can pull out these two. The moles per liter of the concentration of the concentrated, times the volume of the concentrated equals the concentration of the diluted times the volume of the diluted. Okay? We're going to use those equations and we're going to do some examples. Calculate the volume of this concentration of sulfuric acid needed to make this volume of this concentration. Okay? So, if I do, I'm going to do it dimensional analysis way. Moles per liter concentrated times the volume concentrated equals moles per liter of diluted times it by the volume of diluted. Okay, going to change colors to red. Let's pull out the information that we know. Okay, make a diluted solution here. So it's going from 3 mole per liter down to 0.1 mole per liter, and we need 500 mil. So the diluted is going to be 500 mil, or convert it to liters, 0.51234 liters. And what's the concentration of the diluted? We want 0.10 mole per liter. Okay. we got given a concentration, 3.0 mole per litre, and we're missing a piece of information, the volume of the concentrated. Look, that's what we need to find out. Calculate the volume of the concentrated solution. So that's our question mark. Okay? So what we're going to do is take 0.1 moles per litre, multiply it by 0.5 with the 4 zeros. Don't drop your significant figures. Oh, and we want to, I want to erase that, but we want to get rid of the 3 mole on that side, so we're going to divide both sides by 3.0 moles per litre. And that's just going to leave our volume concentrated all by itself, except I drew it too high. Okay, oh, where's my calculator? Here we go. So we need to go 0.1 moles per litre times it by the 0.5 and divided by the 3, and I get, my calculator spits back at me, 0.016 repeater. What's the units? Moles per litre times by litre, litres. Okay. So let's go back to the start. We're looking for a volume. 2 significant figures in 3.0, 5 significant figures in that one, and 2 significant figures there. We're limited to 2 significant figures because this next one is a 6. That second significant figure is going to jump up. So it's going to equal 0.017 litres. Or, if you want to write it the other way, 17 millilitres. I've got that right, haven't I? Yes, I think I have. Always good to double check. 17 mil, 2 sig figs. Okay, let's do another problem. A student wishes to make a certain volume of a certain concentration of hydrochloric acid. What volume of this concentration acid need to achieve this? Okay. 0.7 is greater than 0.2, so that's our concentrated one. Okay, let's set up our equation again. Our concentration of our concentrated times our volume of our concentrated is going to equal our concentration of our diluted times our volume of our diluted. Okay, swap my color again. Okay, my diluted concentration was that 0.200, don't drop your significant figures, moles per litre, and my volume of a diluted is right next to it, that 500.0. Ooh, what am I missing? I'm writing it in millilitres like a fool. I need litres so it cancels with the bottom of the moles per litre. 5000 litres, that's a lot better. Okay, what volume of our concentrated, so that's our unknown, so we'll leave that in there, and the concentration of the concentrated is 0.700 moles per litre. Okay, so to find VC by itself, we're going to take 0.200 moles per litre. We're going to multiply it by the volume, litres, and we're going to divide it by the 0.700 moles per litre. And that's going to give us our volume needed of the concentrated to make the dilute. 0.2 into my calculator, multiplied by 0.5, and divided by 0.7. And it spits back at me 0.142857, that'll do. Litres is my unit for that. Okay, let's look at our sig figs. We've got 4 sig figs for the 500 ml. We've got 3 for that concentration and 3 for that 3, 3, 4. We're limited to 3. Sig fig 1, sig fig 2 is the 4. Sig fig 3 is the 2, but sig fig 4 is 8. So that's third one is going to jump up 0.143 litres to 3 sig figs. Or you can write it as 143 millilitres. Alright, example 3. Find the concentration produced, so slight change, when 50 ml of 1 ml sodium hydroxide is added to 250 ml of water. Here's the little trick, that added to. Okay, so we still start with the same moles per litre of the concentrated times volume of the concentrated, moles per litre of the dilute times the volume of the dilute. Okay, calculate the final concentration produced when something is added to water. So we're asking for the diluted concentration. I'll change colour. Or where do we want to go? The dark green? Okay, so we're asking for the concentration of the diluted. That's our unknown. And our volume of our diluted, notice that it says when that is added to 250 ml of water. Okay, so our initial volume was 50 ml. So we can put that as our volume of our concentrated. So 50 ml in litres is 0.0500 litres. And it's going to end up as 50 plus the 250. Don't be tricked with the added one and put 250 on the right. It's 0.0500 plus 0.2500 litres. That's the 300 essentially. The 300 mil, so it's 0.30000 litres. Did I add in too much zeros? I don't know. Okay, our concentration of our concentrated, it started at 1.0 moles per litre. So to find, this is our unknown, we're going to have to do a little bit of rearranging. Our concentration of our dilute is going to equal 1.0 moles per litre times by the 0.0500 litres. Oh, I've gone too soon because I want a divided by in there. Divided by the volume, which was 0.3000 litres. I don't need that bracket around there. Superfluous bracket. Okay. 1 times something is just itself, 0.05 divided by 0.3, okay, is going to give me 0.16 repeater. That's a familiar number. We had that in the last problem, didn't we? Moles per litre. Okay, that's what the calculator spat back at me. Let's check our sig figs. 50.0 is 3, 1.0 is 2, 250.0 is 4. We're limited to the 2. Okay, 1 is the first, 6 is the second, but there's a 6 after that. So it's going to jump up to 0.17 moles per litre to 2 sig figs. Alright, so there's a worked example from the text. I'm going to talk about some dissolution reactions in the next video. Thanks for your time.